Every year, Americans spend over $200 billion on meat for protein. Every year, researchers quietly publish studies confirming that some of the most protein-dense foods on Earth are not in the butcher's case. They are growing in gardens, floating in ponds, spreading across roadsides, rising from dry soil in places where meat was never an option and the people were stronger for it. Here is what the modern food industry never had reason to tell you. Oldest civilizations on Earth did not have access to feedlots or refrigerated supply chains. What they had was observation, generations of careful, empirical observation about which plants kept people upright, functional, and strong through hard seasons. And many of those plants are still here, still growing, still containing everything they always contained. Today, we are breaking down 13 plants with protein content that rivals or exceeds common animal sources, gram for gram, per calorie, or in the specific amino acid profiles that matter most to a body over 60. These are not nutritional curiosities. Ancient physicians prescribed them. Warriors carried them on campaigns. Civilizations built their physical strength around them. And modern researchers are now confirming what traditional cultures never doubted. Pay attention to number 7. It is something the United States government has spent over $500 million in the last decade trying to destroy, while populations in Asia have been eating it as a staple food for 2,000 years. And stay with us for number 5. There is a story embedded in that entry about a man who collapsed in a desert, asked to die, and then walked for 40 days on what researchers now recognize as a near-perfect recovery meal. That story changes how you think about what food is for. Number 1 is a plant that industrial agriculture quietly replaced with an inferior version, not for nutritional reasons, but for commercial ones. Most people never noticed what disappeared. Let's begin. Number 13. Green peas. Most people think of green peas as the vegetable they pushed around their plate as a child. The ancient world thought of them differently. The book of Ezekiel, chapter 4, contains one of the most nutritionally specific passages in all of ancient literature. The prophet is instructed to make bread from a precise blend of wheat, barley, beans, lentils, millet, and spelt. Modern nutritionists who have analyzed that combination have found it to be a remarkably complete protein source. Field peas grew alongside those crops in the same soil, in the same agricultural tradition, not as decoration, but as load-bearing nutrition. Ancient Egyptians cultivated peas approximately 800 years ago. Greek and Roman physicians documented them as food for people performing sustained physical labor. The ancient world's version of a reliable protein budget, one cooked cup of green peas delivers approximately 9 grams of protein. What makes that significant is not just the quantity, it is the quality. Peas contain all 9 essential amino acids, which is genuinely uncommon among plant proteins. Most plant sources are deficient in 1 or 2 essential amino acids, which limits how efficiently the body can actually use them. Peas are an exception. Laboratory analysis of pea protein shows a digestibility score approaching 0.89 on a scale where 1.0 is maximum, placing pea protein closer to egg white than to most other vegetables. For anyone over 60 whose body requires complete protein to maintain muscle mass that naturally declines with age, that completeness matters as much as the raw quantity. Here is something most guides omit entirely. Pea protein contains a specific branch-chain amino acid ratio that researchers studying sarcopenia, the age-related muscle loss that affects roughly 1 in 3 adults over 60, have flagged as particularly relevant. The leucine to total protein ratio in peas is higher than many assume, and leucine specifically functions as the trigger signal for muscle protein synthesis. You are not just eating protein, you are eating the signal that tells the aging body to build with it. Steam for 4 to 6 minutes at temperatures below 85 degrees Celsius. Extended boiling degrades the protein structure. That is why the color shifts from vibrant green to military drab. That color change is a biochemical signal, not an aesthetic one. Something meaningful was lost in the water. Lightly steam and eat immediately. Add to soups in the final 2 minutes of cooking. Blend cold with mint and lemon. The moment the color goes dull, The damage is done. The pea does something else the ancient world understood intuitively. It fixes atmospheric nitrogen back into the soil, making the ground more productive for everything planted next. It was never just food. It was infrastructure. Number 12. Stinging nettle. This plant introduces itself memorably. Brush against it once, and you remember it for hours. Roman soldiers, stationed in the cold provinces of Britain, rubbed fresh nettles on their legs before long marches, not as punishment, but as medicine. The stinging compounds stimulate circulation in the tissue they contact. Those soldiers were performing a crude but effective warm-up protocol for muscles that would be asked to carry armor across cold, wet ground all day. They also ate it, because in a military campaign where protein sources were limited and the body's demands were unlimited, nettles were among the most nutritionally complete plants available in temperate Europe without cultivation. Stinging nettle contains approximately 6 grams of protein per 100 grams fresh weight, a figure that understates its value significantly, because that protein arrives alongside iron, calcium, magnesium, potassium, and vitamin K in concentrations that exceed most cultivated leafy greens. More critically, nettle provides boron, a trace mineral that research has found plays a decisive role in how efficiently the body uses the magnesium and protein it receives. This is the compounding effect that supplements rarely replicate and that the Roman military discovered through observation, centuries before biochemistry had the language to explain it. There is an additional preparation detail that almost no wellness source mentions: the blanching water. The 60 seconds of boiling required to neutralize the sting draws water-soluble minerals, including silica compounds, associated with connective tissue integrity, into the liquid. Traditional European herbalists did not discard that water. They drank it, or added it to soups. The liquid left in the pot after blanching nettle is a concentrated mineral broth that most modern cooks pour straight down the drain. Harvest young spring growth, the top 4 to 6 inches, wearing gloves. Blanch. 60 seconds in boiling water. Use exactly as you would cooked spinach. Dried nettle as tea delivers meaningful protein and minerals year-round. If nettles are growing near you, you have a free protein source that Roman soldiers valued enough to carry across Europe. Number 11. Pumpkin seeds. Every autumn, millions of Americans carve pumpkins and throw the seeds into the compost. Native American communities across the continent did not do that. Pumpkin cultivation in Mesoamerica dates back approximately 10,000 years, making the cucurbit family among the oldest cultivated food plants in the human record. The seeds were dried and stored as a primary protein and fat source through winter. Nothing was discarded. The seed was understood as the most nutritionally dense part of the plant and treated accordingly. What we now toss into yard waste bins. Entire civilizations carried through winter on 1 ounce of pumpkin seeds delivers approximately 9 grams of protein, more than the same weight of ground beef. But the mineral profile is where pumpkin seeds become genuinely remarkable. 1 ounce provides approximately 40% of the daily recommended intake of magnesium. Magnesium is required for over 300 enzymatic reactions in the human body, including every step of protein synthesis. Without adequate magnesium, the body cannot efficiently use protein from any source, animal or plant. Studies suggest up to 50% of adults in developed nations are deficient in magnesium without knowing it. Here is what most guides omit: pumpkin seeds contain a specific form of vitamin E called gamma-tocopherol, which is distinct from the more common alpha-tocopherol found in most supplements. Research suggests tocotrienols demonstrate antioxidant activity in lipid membranes, exactly the cellular environment where aging accelerates most rapidly. The form matters. The seeds contain the form worth having. Lightly toast raw pumpkin seeds in a dry skillet over medium heat for 3 to 5 minutes, stirring constantly until they puff slightly. Season with sea salt only after removing from heat. Salt added during toasting draws moisture unevenly and slows the puffing. 1 ounce daily as a snack, scattered over salads or blended into smoothies. The seeds being composted every October contain one of the most mineral-dense protein sources available. Number 10. Amaranth. In 1519, Hernán Cortés arrived in Mexico and began dismantling the Aztec Empire. He confiscated gold, he destroyed temples, he outlawed ceremonies, and among his first and most deliberate acts of cultural destruction, he banned the cultivation of amaranth, punishable by death. That decision tells you everything about what amaranth meant to the Aztec civilization. It was not a side crop. It was not a ceremonial grain used occasionally. It was central to the physical strength of a civilization that built cities larger than any in Europe at the time. Cortés understood that if you control the protein supply, you control the people. Amaranth was the protein supply. One cooked cup of amaranth delivers approximately 9 grams of complete protein, with all 9 essential amino acids, including lysine, which is notably deficient in most grain crops. Lysine is critical for muscle repair and calcium absorption. The lack of lysine in wheat is one reason bread-centric diets historically produced populations with lower muscle maintenance than legume and grain combinations. Amaranth solves the lysine problem that wheat cannot. Research has also identified a peptide in amaranth called lunasin, the same peptide found in soybeans that some laboratory studies suggest may interact with inflammatory pathways at the cellular level. The science is early stage, but consistent enough to sustain continued investigation. What most guides never mention amaranth leaves are edible and nutritionally comparable to the seeds. The Aztec civilization ate the whole plant seeds as grain, leaves as vegetable, roots as medicine during specific seasonal transitions. The seed harvest received historical attention. The leaves received a different kind of attention in traditional practice. They were fed specifically to people recovering from illness. Contemporary analysis of amaranth leaves shows protein content approaching 3 grams per 100 grams fresh weight, modest by number, but arriving alongside a specific manganese concentration that supports the mitochondrial antioxidant enzyme superoxide dismutase. The whole plant was understood as a system, not a single ingredient. 1 part amaranth to 2.5 parts water. Bring to a boil. Reduce immediately to a low simmer. Cover and cook for 20 minutes without lifting the lid. Soak overnight before cooking to reduce phytic acid content, which meaningfully improves mineral and protein absorption. The Aztecs built one of the most formidable civilizations in human history on this grain. Cortés tried to erase it. It survived. That persistence is itself worth noting. Number 9. Chickpeas. Archaeological evidence from Jericho dates chickpea cultivation to approximately 500 BCE, making them one of the earliest domesticated crops in human history. They fed the builders of the early Islamic caliphates, the armies of the Byzantine Empire, the agricultural communities of the Indus Valley civilization. 3 cultures on 2 continents, with no overlap in religious tradition or geographic contact, all arriving independently at the same conclusion about the same being. When 3 separate civilizations with no contact reach the same conclusion, that convergence is not coincidence. It is observation. The book of 2 Samuel records a moment after David's retreat from Jerusalem. A man named Barzillai and others brought supplies to the exhausted king and his followers. Among those supplies were parched grain, beans, and lentils. Chickpeas would have been among those beans. They were that foundational to survival nutrition in the ancient Near East. 1 cooked cup of chickpeas delivers approximately 15 grams of protein alongside 12 grams of fiber. The fiber matters specifically in the context of protein because it feeds the gut microbiome, which produces short-chain fatty acids that regulate inflammation throughout the body, including the muscle inflammation that follows physical activity. A body with a healthy microbiome recovers faster. Chickpeas build the microbiome while simultaneously delivering the protein. Here is the preparation detail that most people never encounter: the liquid inside a can of chickpeas. It as an egg white substitute in applications requiring protein foam stability. Traditional Middle Eastern cooks, who slow-cooked dried chickpeas in clay pots, retained every drop of cooking liquid. They were not being frugal. They were preserving the part of the preparation that contained the water-soluble compounds that the seed coat releases during long cooking. That liquid, added back to soups and stews, Delivered compounds the drained chickpea alone could not. Soak dried chickpeas for 12 hours. Discard the soaking water and cook in fresh water for approximately 90 minutes at a gentle simmer. The soaking process reduces phytic acid by up to 40%, meaningfully improving mineral and protein absorption. 7,500 years of human cultivation is not coincidence. It is the longest field trial in nutritional history. Number 8. Kudzu. The United States government has spent over $500 million in the last decade trying to destroy a plant. It covers over 7 million acres across the American South, spreading at a rate of up to a foot per day in summer heat. Farmers budget for it. Highway departments run eradication programs against it. Counties hold organized removal days. The USDA classifies it as one of the most problematic invasive species on the continent. In Japan and China, this same plant has been eaten as a staple food for over 2,000 years. The plant is called Kudzu, and the gap between how America treats it and how Asia has always understood it is one of the most extraordinary nutritional oversights in modern history. Kudzu leaves contain approximately 17 grams of protein per 100 grams dried, comparable to many legumes, and exceeding most cultivated leafy greens by a significant margin. The root starch, called kudzu in Japanese cooking, is used as a premium thickening agent and digestive remedy. Traditional Chinese medicine has prescribed kudzu root for over 2,000 years for what practitioners described as conditions of inflammation and digestive weakness. Research has since identified isoflavones in kudzu root, including purulina, found in almost no other plant source that studies suggest may support cardiovascular health and reduce inflammatory markers. With results, researchers consider worth further clinical investigation. What virtually no source in the Western wellness world discusses kudzu flowers, the blossoms, which appear in late summer across the American South, are high in anthocyanins, the same antioxidant pigments that make blueberries nutritionally significant. Traditional Japanese preparations include kudzu blossom jelly, consumed specifically in late summer, when the flowers are most concentrated in color compounds. The flower that Americans walk past on August roadsides is, by anthocyanin content, nutritionally comparable to several cultivated berries. It has been there the entire time. Young kudzu leaves and vine tips harvested in spring before the plant becomes tough. Cooked exactly like spinach or any leafy green. Mild flavor. Entirely approachable. Kudzu root starch, available in Japanese grocery stores and online, as a white powder 1 teaspoon per cup of liquid, as a thickening agent. The flowers are edible raw or made into jelly. Start with the leaves if you have access to the plant. They are free, abundant, and have been feeding populations across Asia for 2 millennia while America has been trying to eliminate them. If this kind of ancient knowledge resonates with you, hit like and subscribe, because what's coming next goes even deeper. Number 7. Hemp seeds. Hemp appears in Chinese agricultural records as early as 2700 BCE. Documented in the Pharmacopoeia, attributed to Emperor Shen Nong as a plant of both nutritional and medicinal value. The ancient Scythians, the nomadic horse warriors, described by Herodotus as among the most formidable fighters in the ancient world, carried hemp seeds as a primary travel food. Viking-age populations used hemp seeds as a staple food source, alongside rope and sailcloth fiber. Civilizations with nothing in common culturally found the same uses independently across thousands of years and thousands of miles. The stigma attached to hemp for decades had nothing to do with its nutritional profile. The nutritional profile never changed. It was exceptional the entire time. 3 tablespoons of hemp seeds deliver approximately 10 grams of complete protein, all 9 essential amino acids, including methionine and cysteine, which are typically the limiting amino acids in plant proteins. The proteins in hemp seeds are primarily edestin and albumin, 2 globular proteins with a molecular structure that human digestive enzymes break down with unusual efficiency. Digestibility scores in published studies have reported figures significantly higher than most other plant sources and comparable to egg white. Here is the specific detail that almost no source discusses a destin. The primary protein in hemp seed is structurally similar to the globular proteins found in human blood plasma. Some researchers in food science have noted this structural similarity and flagged it as a potential reason for the high digestibility scores. The body's protein processing machinery recognizes the molecular shape. Traditional practitioners who observed that hemp seeds seem to restore depleted people faster than other plant foods may have been observing this efficiency without being able to name its mechanism. Hemp also delivers an omega-6 to omega-3 ratio of approximately 3:1, a ratio some researchers consider close to optimal for managing the inflammatory environment that muscle recovery requires. For anyone over 60, muscle recovery is fundamentally an inflammatory management process. Hemp seeds provide both the protein and the fatty acid environment that supports it simultaneously. 3 tablespoons in oatmeal. Blended into smoothies. Stirred into yogurt. No cooking required. No preparation beyond opening the bag. Milt. Slightly nutty flavor that disappears into most foods. Store in the refrigerator after opening. The omega-3 content makes them susceptible to oxidation at room temperature over time. The most effortless protein addition on this entire list. Number 6. Lentils. Open 1 Kings, chapter 19, and read it slowly. Elijah has just called down fire from heaven in front of 450 prophets of Baal. He has won an extraordinary public confrontation, and then a single death threat from Queen Jezebel sends him running into the wilderness alone. He collapses under a broom tree, exhausted, dehydrated, spiritually shattered. He asks God to let him die. What happens next is not a sermon. It is a meal. An angel touches him and says, "Arise and eat." And there beside his head is a cake, baked on hot coals and a jar of water. He eats. He lies back down. The angel returns a second time. "Arise and eat, because the journey is too great for you." The Hebrew word for the cake, described uga, refers specifically to a flatbread made from ground grain and legumes. Researchers who have analyzed ancient bread preparations from that region find they would have included ground lentils as a primary ingredient. The angel did not bring Elijah meat. The angel brought him what we now understand as a near-optimal recovery meal for acute physical and psychological exhaustion complex, carbohydrates for glycogen restoration, complete protein for tissue repair, and the specific amino acid leucine in concentrations sufficient to trigger muscle protein synthesis. Elijah ate, drank, lay back down, then rose and walked 40 days to Horeb. That is a description of complete restoration from complete depletion. The ancient world did not need researchers to tell them what lentils could do. They showed them what to do with it. Lentils deliver 18 grams of protein per cooked cup, more than 3 eggs. More than a serving of Greek yogurt, comparable to a medium chicken breast. The specific amino acid profile includes unusually high levels of leucine, the amino acid that functions as the primary trigger for muscle protein synthesis. When leucine levels in the bloodstream cross a threshold, the body signals the production of new muscle tissue. Lentils cross that threshold. They also contain approximately 6 milligrams of iron per cup, roughly 30% of the average daily requirement. And here is the preparation detail that traditional cooks discovered through observation long before biochemistry had a name for it: lemon. A squeeze of lemon juice, or a handful of tomatoes added after cooking dramatically, improves iron absorption from the same bowl. The vitamin C converts the non-heme iron in lentils into a form the intestinal wall can absorb 2 to 3 times more efficiently. For anyone over 60, managing both protein intake and iron levels, which decline together and produce overlapping symptoms of fatigue and slow recovery, that lemon is not a flavor decision. It is a nutrient decision. Red lentils dissolve into a creamy warming soup in 20 minutes without soaking. Brown and green lentils hold their shape after 30 minutes. Never boil at a rolling boil for extended periods. This degrades protein structure and produces a mushy texture that signals overcooking. Simmer gently. Add lemon juice after cooking. The angel knew what it was doing. Number 5. Moringa. There is a tree, that grows up to 15 feet in its first year, can be harvested multiple times per season, thrives in poor dry soil that defeats most other crops, and contains a nutritional profile so extraordinary that international health organizations have deployed it specifically in acute famine situations where conventional agriculture has failed. The Arabic medical tradition documented moringa in the 13th century as a plant of remarkable sustaining power. Ayurvedic tradition classified it as a rasayana, a category of herbs associated with longevity, strength, and the reversal of bodily depletion. Across sub-Saharan Africa, South Asia, and Southeast Asia cultures, with no ancient contact moringa, arrived at the same designation independently, the tree you plant when you need to ensure that people do not starve. 100 grams of dried moringa leaf powder contains approximately 27 grams of complete protein with all 9 essential amino acids. Gram for gram. The dried leaves deliver roughly twice the protein of yogurt. They also contain 4 times the calcium of milk by weight, 7 times the vitamin C of oranges, and 3 times the potassium of bananas, all from one plant. The specific compounds include isothiocyanates that activate NRF2, the master regulatory switch for the body's own antioxidant defense systems. NRF2 activation prompts cells to produce their own protective enzymes, including glutathione, which the body manufactures internally rather than obtaining from food. This pathway declines significantly with age, and its decline accelerates oxidative damage in muscle, neural, and cardiovascular tissue simultaneously. Moringa is not delivering antioxidants. It is activating the machinery that produces them. Here is the preparation detail that matters most, and that most guides overlook: the temperature threshold. Temperatures above 70 degrees Celsius degrade moringa's vitamin C content measurably. Fresh leaves added to a boiling pot lose much of what makes them worth adding. Traditional preparations in South Asia often involved wilting fresh leaves over very low heat or adding them raw to dishes after cooking. The communities that planted moringa during famines were not following tradition. They were following results. And the results consistently included the same preparation instinct: gentle heat, ordinone. 1 teaspoon of dried moringa leaf powder, stirred into warm water or broth not boiling. Mil. Slightly grassy flavor that blends into almost anything. Fresh leaves added to soups after cooking. Used in salads or sautéed briefly over the lowest possible heat. The miracle tree earned its name not from legend. It earned it from the observable fact that communities planted it when everything else failed and the people did not starve. Number 4. Purslane. In 1992, a researcher named Artemis Simopoulos published a paper in the New England Journal of Medicine that quietly unsettled everything nutritionists thought they knew about plant nutrition. She had been studying rural Greek islanders, people with remarkably low rates of heart disease and unusually robust physical condition into old age. When she analyzed their diet, looking for the variable that explained their health outcomes, she found purslane, a sprawling, fleshy plant they added to salads and stews without a second thought. The same plant most American gardeners spend their summers pulling out and composting. Ancient Greek physicians described purslane as a cooling medicinal food. Traditional Mexican cooking has used it as verdolaga, a valued ingredient in soups and stews for centuries. It appears in the culinary records of the Mediterranean, Middle East, India, China, and Central America simultaneously, 5 separate ancient cultures across 3 continents, arriving at the same plant through independent observation. When that pattern of convergence appears, the reason is not cultural coincidence. The reason is that people who ate it regularly were observably stronger, healthier, and more resilient than those who did not. Purslane contains a complete amino acid profile, all 9 essential amino acids, making it one of the only leafy vegetables that qualifies as a complete protein source. The protein content per calorie exceeds most cultivated greens significantly. You would need approximately 3 times the volume of spinach to obtain the same protein per calorie ratio that purslane delivers. And then there is the omega-3 content. Purslane is the only land plant that contains meaningful amounts of EPA, eicosapentaenoic acid, the long-chain omega-3 typically found only in fatty fish and marine algae. This is not the short-chain ALA that most plant sources provide. It is the form that anti-inflammatory pathways in the human body can use directly. Without the conversion step, that becomes increasingly inefficient with age. Most land-based omega-3 sources provide the raw material. Purslane provides something closer to the finished product. Here is the preparation detail that destroys most of that benefit: heat. The EPA content in purslane is heat-sensitive at relatively low temperatures. The Greek preparation: fresh purslane, olive oil, lemon, salt preserved the EPA because nothing was cooked. When purslane is stirred into hot dishes, add it in the final 30 seconds, or after the heat is off. The plant Simopolis found associated with remarkable cardiovascular outcomes was eaten raw or barely warm. That was not coincidence. The plant is almost certainly growing in your garden right now as a weed. It has always been there. The decision to compost it rather than eat it is recent, cultural, and nutritionally costly. Number 3. Spirulina. The Book of Exodus describes the Israelites in the wilderness, subsisting on manna, a substance appearing on the ground or water surface each morning. Small, white, gathered and consumed. Scholars have proposed various natural explanations across centuries of theological inquiry. What is documented history, rather than speculation, is this: the Aztecs harvested spirulina from Lake Texcoco and pressed it into dried cakes, called tequilotl, sold in markets alongside corn and beans as a primary protein source. The Kanembu people around Lake Chad in North Africa have harvested and dried spirulina for centuries, consuming it as dihe, a food still eaten today. Two cultures on two continents, separated by an ocean with no recorded contact. Independently developed harvesting and preservation methods for the same microorganism. NASA studied spirulina for long-duration space missions. When cargo weight determines survival, and every gram must justify its presence, spirulina's nutritional output per gram is difficult to match with any other food source. Spirulina is approximately 60 to 70% complete protein by dry weight. Beef is approximately 26%. Chicken is approximately 31%. Spirulina does not merely compete with animal proteins. It nearly triples them by proportion. 2 tablespoons deliver approximately 8 grams of highly bioavailable protein alongside iron, B-vitamins, beta-carotene, and phycocyanin, the blue-green pigment that is the subject of active research. Studies suggest phycocyanin inhibits the production of certain pro-inflammatory compounds through mechanisms that operate at the level of enzyme inhibition rather than simply antioxidant neutralization. The distinction matters. Antioxidants mop up damage after it occurs. Enzyme-level inhibition intervenes earlier in the inflammatory cascade. The science is still developing, but the mechanism proposed is specific and testable, the kind of finding that sustains continued investigation. Here is the preparation detail that most sources miss: temperature. Heat above 60 degrees Celsius begins to degrade phycocyanin content. This means any spirulina added to a hot smoothie, hot tea, or cooked dish is delivering diminished amounts of the specific compound that makes it most interesting. Cold preparation is not optional if phycocyanin is the target. Cold water, citrus juice, room temperature smoothies. Begin with 1 teaspoon in cold liquid. The flavor is distinctly oceanic and assertive. After 2 weeks, most people find the taste unremarkable. Masking in fruit smoothies is entirely legitimate. The ancient world found this protein on the surface of desert lakes and understood immediately what it was. Not superstition. Survival intelligence. Number 2. Black soybeans. Everyone who follows plant-based nutrition has heard of soybeans. Yellow soybeans, edamame, tofu, tempeh. These are the familiar forms. What almost no one in the Western world knows is that the black-seeded variety, glycine max, was the original cultivated form in ancient East Asia, and that the two varieties differ meaningfully in their nutritional profile in ways that matter significantly to anyone paying attention to aging physiology. Traditional Chinese medicine categorized black soybeans separately from yellow soybeans because practitioners observed different therapeutic effects. Shennong's Pharmacopoeia describes black soybeans specifically as tonifying for what was understood as vital essence, a concept that maps closely onto what we now call mitochondrial energy production and metabolic resilience. Traditional Japanese families elevated black soybeans to ceremony. Kuromain black soybeans simmered slowly with soy sauce. Eaten as a ceremonial food during New Year, celebrations specifically for their association with health and longevity. The ceremonial designation was not arbitrary. It reflected accumulated observation about which foods correlated with the outcomes people most wanted. Then industrial agriculture replaced them with yellow soybeans. Higher yield, easier to process into oil and meal, more profitable per acre. The black variety was quietly set aside. Black soybeans deliver approximately 29 grams of protein per cooked cup, comparable to a 4-ounce chicken breast. The protein is complete. But the distinction from yellow soybeans is in the anthocyanin content. The black seed coat is dense with cyanidin, 3-glucoside, the same anthocyanin that makes blueberries nutritionally significant in concentrations that exceed many cultivated berries by a meaningful margin. When you cook black soybeans, the cooking liquid turns a deep purple-red. That liquid is not waste. It contains meaningful concentrations of the water-soluble anthocyanins, the part of the preparation that is most fragile, most bioactive, and most easily lost to heat and time. Traditional Chinese and Japanese preparations retained that liquid specifically as a medicinal component. The part most modern cooks pour down the drain was the part traditional practitioners considered most valuable. Here is a preparation detail that has almost entirely disappeared from modern food culture: slow roasting dried black soybeans before soaking. Traditional East Asian preparations sometimes involve dry roasting the whole bean over low heat before hydration, a process that Maillard reaction chemistry suggests would develop flavor compounds while leaving the anthocyanin-rich seed coat intact. Since the black pigment concentrates in the outer layer rather than the starchy interior, the roasted flavor transforms the final dish in ways that modern cooking methods, which prioritize convenience over layered preparation, have largely abandoned. Soak dried black soybeans for 12 hours. Cook in fresh water at a gentle simmer for 90 minutes until just tender. Do not discard the cooking liquid. Use it as a broth base, or drink it warm. The flavor is earthy, slightly sweet, entirely different from yellow soybeans. Available in Asian grocery stores, health food stores, and online. Most mainstream supermarkets do not carry them, which is the most accurate summary of what happened to them. Number 1. Purslane's ancient counterpart, Tepary beans. Before the story ends, there is one plant that most people following even dedicated plant-based nutrition have never encountered. Not because it lacks evidence, because industrial agriculture made a commercial decision about it that was never reversed. The Tepary bean, Phaseolus acutifolius, is indigenous to the Sonoran Desert and has been cultivated by indigenous communities across the American Southwest and northern Mexico for approximately 5,000 years. It grows in conditions that would kill most cultivated crops: sande, low-nutrient desert soil, minimal water, temperatures that would collapse conventional bean agriculture entirely. And in those conditions, it produces the Tohono O'odham, people whose traditional territory spans what is now southern Arizona and northern Mexico, built their agricultural tradition around the Tepary bean, not as a backup food, as the primary protein crop, the cornerstone of a diet that sustained population health across a landscape where agriculture seemed nearly impossible. One cooked cup of Tepary beans delivers approximately 19 grams of protein, exceeding chickpeas, exceeding black beans, approaching lentils. The amino acid profile is complete, but the distinguishing characteristic is the soluble fiber content, which exceeds most other legumes and includes a specific form of resistant starch that ferments slowly in the large intestine, producing short-chain fatty acids over a longer time window than other legumes. This slow fermentation pattern produces a more gradual and sustained effect on blood glucose and gut microbiome composition. Agricultural researchers studying drought-resistant crops have found that the Tepary bean produces meaningful yields with approximately 1/4 of the water required by common bean varieties. At a moment when water scarcity increasingly limits conventional agriculture, a protein crop that evolved to thrive in drought conditions is not a historical curiosity. It is an agricultural answer that has been available for 5,000 years. The USDA conducted extensive research on Tepary beans in the mid-20th century, documented their resilience and nutritional profile, and then watched as conventional agricultural economics selected against them in favor of higher yield varieties bred for irrigated conditions. The Tepary bean was not forgotten because it was inferior. It was set aside because the infrastructure of industrial food production was not built around it. Traditional preparation: soak dried Tepary beans overnight in cold water. Drain. Cook in fresh water at a gentle simmer 2 to 3 hours, as they require longer cooking than most beans. The result is a firm, nutty bean with an earthy, slightly sweet flavor, distinctly different from pinto or black beans. Indigenous preparation often included cooking with dried chili, salt, and epizotin herb that traditional cooks observed reduced the digestive discomfort associated with beans, a function researchers now attribute to its volatile oil compounds, interfering with the gas-producing fermentation that occurs in the upper digestive tract, rather than the beneficial fermentation lower down. That herb combination was not arbitrary seasoning. It was a preparation protocol refined over thousands of years, available through specialty suppliers, health food stores, and indigenous food sovereignty organizations that have worked to reintroduce Tepary beans to commercial availability. The plant survived 5,000 years in one of the harshest growing environments on Earth. Industrial agriculture's indifference could not eliminate it. It is still here. Everything on this list has something in common, and it is not protein. What every plant on this list shares is that it has been minimally processed, or not processed at all, since the moment it left the soil. Green peas straight from the pod, nettle leaves after 60 seconds of heat, pumpkin seeds lightly toasted, amaranth soaked and simmered, black soybeans cooked and never drained. The active compounds in these plants, the phycocyanin in spirulina, the cyanidin in black soybeans, the EPA in Purslane, the isothiocyanates in Moringa, the lunacin in Amaranth share one critical vulnerability. They are fragile. Extended heat, industrial processing, high-pressure extraction, bleaching. Refining each step in the industrial food chain that transforms a raw plant into a packaged product destroys a percentage of what made that plant worth eating in the first place. Ancient communities did not have the biochemistry to name these compounds, but they had something more durable: generations of observation about which preparations worked and which did not. They noticed that lentil flatbread restored Elijah, that kudzu leaves kept communities fed through difficult seasons, that the cooking liquid from black soybeans was worth preserving. They encoded that observation into cultural practice, into recipes, into ceremonies, into agricultural traditions. And then, industrial agriculture replaced those practices with processes optimized for shelf life and profit margin rather than bioavailability. This is the thread that runs through every entry on this list. The question worth sitting with is this: if the most nutritionally significant compounds in these plants are concentrated in the parts most commonly discarded, the nettle water, the black soybean broth, the purslane eaten raw, what else has modern food culture been systematically composting that the ancient world understood was valuable? That question does not have a comfortable answer, but it is the right question. If this resonated with you, hit like and subscribe. Every video on this channel follows the same discipline: ancient evidence, modern science, practical preparation, no exaggeration. Share this with someone who is paying attention to what they eat and would benefit from knowing what they might be missing. And leave a comment below. Tell us which plant surprised you most, and what topic you want us to go deeper on next. We will be here.